Cramers rule is another good application of determinants. Cramers rule lets you solve a system like this: ax equals b, one variable at a time, provided that A is a square matrix and that its determinant is non-zero. So here is sort of a pictorial representation of Cramers rule. What you do to solve a system like this for x, y, and z, to solve for x, well, for all of them, the denominator is the determinant of the coefficient matrix. And to solve for x, you take the determinant of this, which this is just the coefficient matrix, but it's with these constants put into the x column. And same thing for y, you put the constants into the y column. And for z. So this is another way you can solve a system. Now, a good question here I've got written out is, why would you do this when you could just row reduce the thing and solve for all the variables at once? And the answer to that is, most of the time, if you're trying to solve something, you probably just want to type it into Octave or type it into your calculator and just get the answer. But there are a lot of places where this is maybe more appropriate. And I've got just the few examples I could think of written down here. If you're writing a computer program and there's a little part in the program where you need to solve part of a system of equations, then you could use this. The advantages would be it would keep the code simple, and you could probably load in a big linear algebra library and get that to solve it for you. But maybe you don't want to do that. Maybe you bloat your code, or maybe you're writing on a microcontroller and you either don't want or don't have a library that you can use. Another thing is, if your matrix is filled with complex numbers instead of real numbers, row reducing stuff like that can be a real pain. So this might be an easier way to go. And another one, and I'm actually going to do this. What if you need to solve a system in Excel? Well, in Excel you can do determinants, but Excel can't do row reduction. So let's look at this. Let's look at an example here. Solve this system using Cramers rule. Use Excel or Google Sheets to do the computations. All right, I'm going to write the first thing out here. Our x is going to be, on the bottom we'll have the determinant of our coefficient matrix. So it's going to be 1, 2, 4, then 2, 3, 1, and 5, 5, 7. And on top we have the same thing except for in the first column. So we've got 2, 3, 5, 4, 1, 7. But in this first column, we're going to put these guys. So that's how we'd solve for x. And I'm going to be lazy here and say for y, we would do essentially the same thing, except for, let's see, this first column is going to be 1, 2, 5. And then the middle column will be the 1, 1, 1. And z we'd get a similar way. But let's do this in Excel, because I want to show you how to use Excel to do this. Okay, here's an Excel window. And let's see, I think I can scroll this up so that you can see more of it. Yeah, let's do x first. So I'm gonna put in the denominator determinant. I'll put it in down here. Let's see, 1, 2, 4, 2, 3, 1, 1, 5, 7. And the way that you do this to get a determinant is type equals and then m determ, and then select the stuff and hit equal, and it gives you the determinant right there. So now I'm gonna copy all of this and paste it up here. So this gives me the notice it copied the determinant thing too, the determinant calculation. So I can just come up here in column A and replace this with, or column A, which is for x, replace that with 1, 1, 1. And that gives me x is equal to 12 over 18, which of course is 2/3. So let's solve for y and z while we're at it. So I'm going to copy this back to here. So my y, I'm going to put the 1, 1, 1 here in the middle. This gives me negative 3 over 18. What is that? Negative 1/6. Let me write this a little better. So x is this. Y is negative 1/6. And z, so again, I'll take this, put it all in there, and we'll replace the z column with 1, 1, 1. So that gives me 3 over 18, or 1 over 6. And of course, you could do these determinants by hand if you wanted to, or you could do them, using your calculator or using Octave. But anyway, I just wanted to show you this to have sort of an example of using a spreadsheet to do your determinants. All right, we've got another example, but I'm going to put that in the next video.